Hi leaders, good afternoon. I trust the lunch was enjoyable. We are 5 minutes behind, but don't you worry, we will make up the time. I said to you earlier before we had the break for lunch that there was going to be a little bit of an amendment to the program. We do have a very special guest who we've been asked to give a few minutes of time to address the audience. She is the Vice President of the African Space Council. She's also the Chair of the Malawi Space Agency Task Force. Her name is Dr. Thandi Vundula, and I want to call her on the stage. She will speak for about 6 minutes, letting us know about the exciting stuff that is happening in the space of the two organizations I mentioned. Over to you, Dr.
Thank you very much, Maud. All protocols observed. Good afternoon, everybody. I know it's the graveyard session, but so I won't take too much of your time. As she said, my name is Thandi Vundula. I'm the chair of the African Space Council. And just to give you a little bit of background, in 2018, the 13th session of the African Union Assembly, they adopted the statute for the African Space Agency. And this comes from work that was done before in about 2013, when the ordinary session of the Executive Council adopted a decision on recommendations for Africa to develop a well-structured space policy and strategy to guide the member states to implement a globally competitive outer space program. This outer space program for the continent was to look at critical issues like developing local capacity in Earth observation, satellite communication, navigation and positioning, space science and astronomy, among others. So the African Space Agency is being established as an organ of the African Union, which will be dedicated to promoting, advising and coordinating the development and the utilization of space science and technology in Africa, and along with the associated regulations for the benefit of the continent. Now, bear in mind, I think you were informed, there are a number of heads of space agents, African space agencies that are present, that have been present with you the last couple of days. And as we know, all the countries are at different developmental stages. So the African Space Agency would be there to establish sort of the framework that would guide the continent in these different areas. So it would be looking at promoting and coordinating the implementation of the African space policy and strategy, which already have been adopted. So the African Space Agency will work with other national, because people often have questions about whether, sort of, is it trying to take over, is it trying to control? The African Union recognizes the sovereignty of the member states, and it will be the African Space Agency will work with national and international institutions and coordinate the continent-wide regulatory framework for space activities on the continents. In terms of governance, I've been introduced as a Vice President of the Africa Space Council. The Africa Space Council is part of the key governance structure that oversees the space agency. And two members each from each of the 5 African Union regions, and Southern Africa, East Africa, and so on. So we were, as of February this year, at the session of the African Union Heads of State and Mission, 8 of us actually, were elected by the continent. So it really depended on the profiles and the combination. And the African Space Council is headed by Dr. Tidiane Ouattara, who unfortunately could not be here with us today. I'm the Vice President, and I have a number of members. I have Dr. Ishan Mundio from Namibia, who's also here. The two of us come from the Southern African bloc. He's a member of the Space Council, so he is here with me today. So, as I was indicating, the African Space Council governance is the top layer of the governance structure, and it will be supported by an advisory council committee, which would be drawn from elected commissioners from the African Union, So beyond the council, we'll be working with an advisory committee and with various experts, supported by the African Union Secretariat, and then below that is the Director General of the African Space Agency. So we, as the African Space Council, will report on the progress of the African Space Agency to the AU Council through the AU Assembly. And that's essentially the way the structure is actually going to work. But we will be calling out and reaching out to experts in the space sector across the continent for various committees, subcommittees, and so on. Okay. So that's basically where we are. We were elected in February, as I indicated. We got the wheels of these large administrative agencies work a little slow, and we got our letters of appointment about a month ago. So we're in the process of being established. The African Space Agency, the location of it was, I think there was bidding across different countries across the continent, and Egypt is going to host the African Space Agency. So that's where it's ultimately going to be. They've already put up a building there, and as we progress and start the recruitment of the staff, that's where it'll be hosted. And my second hat is that of the chair of the Malawi Space Agency Task Force. So Malawi, 3 years ago, also decided to establish a space agency, and last year appointed a space agency task force. So our members are global, because we recognized we hadn't had a space agency in country, so the expertise was not there. So we work with global experts, and one of my members, I think a number of you probably know him, is he sitting here? Yes, Dr. William Makwinja. And I've also come with Professor Mlato. Those are both members of the task force. We work globally, as I said, so we have Malawians in the diaspora working with NASA and in California, and they're all part of the task force that are setting up Malawi Space Agency. So I think with those few words, just to introduce what we're doing, and we hope the continent will contribute. I think we will be drawing on expertise and experiences from people across the continent, and I wish you a very successful conference.
Thank you so much to you, Dr. Thandi. Very exciting things taking place at the African Space Agency. We'll be watching it with keen intent. Do keep us informed as things unfold in coming weeks and months. Thank you so much. Ladies and gentlemen, we're going to move on with the rest of our program. And this time it is a showcase session focused on integrated environmental monitoring, where we're going to be exploring comprehensive systems of satellites and remote sensing technologies for continuous monitoring of environmental parameters. And this is going to be moderated by the principal researcher at the CSIR, Dr. Heidi van der Venter. And for those who are joining us for the first time, we are using Slido, which is what is on your screen, for the question and answer. So you will log on to slido.com, slido.com, and then the number you will type in for this particular session is the number that's on your screen, 1432412. And that is the place where you will ask your questions and pose your comments. We will not have a formal question and answer where people will raise their hands. I'm also the director of ceremonies, but also the director of time. It's very important, especially after lunch. Everyone's energy is down. Everyone wants to go home. I know that. And we need to make sure that we end on time. I had a conversation, a very lengthy conversation with Dr. van der Venter, and we're friends. Are we friends? We're friends. So for those who are just joining for the first time, 15 minutes to go will show the green, 10 minutes to go will be the yellow, and when there's 5 minutes left in the presentation, it will be the red. It's very important that we stick to time. I'm sure you noticed in the previous session, the last speaker had to quickly rush through because someone went over time. We're not going to do that. It's the final session. You're the curtain call, and we're excited to hear from you. So over to you, Dr. van der Venter, to you and your team, and we'll speak after the session. Thank you.
Good afternoon, everyone. May I please ask for the speakers of this session just to come to the front and please be seated. On the hard copy programs, you will see that there is a change of the speakers that is noted online. Lulu has changed the program for us online. So the first two speakers, Mr. Riza Mazarire and Ms. Kanyisa Mpisani, would not be able to attend anymore, but we still have 6 speakers to speak. And our first speaker, I'm going to announce names and companies, but they're going to read their own titles just to keep short of time. And they were informed that if they speak 15 minutes, there's no time for questions, and they need to meet up with you who have questions at the networking session. All right, so if they speak faster, there's time for questions. Good. Our first speaker is then Dr. Tulang Mokele from the Human Science Research Council. Thank you.
Morning all. We are get up. Thank you very much. As indicated and as introduced by the program director, I'm Tulang Mokele. So I'm representing a team of researchers from the Human Sciences Research Council. Interestingly, I met Prof outside there and he said, "Oh, you're from HSRC. Finally, we are going to have people who can, bring in the issue of application to the ground or to the people." So in this presentation, I'm looking at flooding vulnerability in informal settlements and then looking at the spatial policy implications. As we all know, South Africa is affected by latest climate change, especially flooding. As we know, the experiences in the KZN, Eastern Cape, and here in Gauteng, particularly in Mamelodi. And then informal settlements are mostly affected by this flooding because they are often located in areas that are not suitable for residential development, or they are, in most cases, located in areas that are vulnerable to seasonal flooding. And then what we also need to note is that, even though these people or these residents are normally located in areas that they were not supposed to be located at, we as the social scientists, we always say that their health, their well-being is of high importance. So we are sort of like proposing some ideas so that even though they are located where where the government or the policymakers don't want them, how do we find an amicable solution for such cases? So in our recent census data, we have noticed that in terms of trends, the number of informal dwellings from 2011 to 2022 has decreased. But then when you look at the metros, city of Tshwane has actually seen an increase of 5.9% increase. And then this, in most cases, these informal dwellings, they make our standalone shacks and then shacks in the backyards, of which we all know that the standalone shacks will make our informal settlements. Therefore, our intention for this study was to look at informal settlements that are highly vulnerable to flooding around the city of Tshwane. So as indicated, we made use of census data from StatSA, and then informal settlements data from Department of Human Settlement, and then we also used flood risk layer data from South African National Space Agency, and then we also made use of Google Earth Engine for time series data from 2011 to 2024. And then we looked at geovisualization, and then we went further and tried to develop a vulnerability index model. So this is our model flow. As you can see, we first imported the data and prepared the data using like that time series data. And then we looked at, for instance, a topographic position index, and then we also considered the elevation data. And then in our final model, we sort of like looked at distance, elevation, and vegetation, as well as wetness. And then our final score, we sort of like categorize our final score as low risk up to higher risk areas. So this is just the distribution of informal settlement across the city of Tshwane, for those who are not familiar of city of Tshwane. And then this is just an overlay of the flood risk layer on top of the informal settlements across Tshwane. As you can see around Mamelodi here, there are some that are falling within the flood risk layers. Okay, as indicated, there was, for instance, in Mamelodi, there were 2 informal settlements that were completely in the floodplain or flood risk area. And then, for instance, we had a case of Mafuso informal settlement, which was flooded in December 2022, and then it happened again in 2023. The same informal settlement was flooded. So this is just the example of the situation. As you can see, this is without the flood risk layer. You can see that, for instance, this informal settlement is completely within the flood zone or flood risk area. And then some of this, the informal settlement as well. Okay, this is just another example of an informal settlement that is overlapping with the flood risk area. And then, for instance, this is our model results, the flood vulnerability index. As you can see that, for instance, we looked at the distance from the permanent water, and then, like indicated, we look at the topographic position index. But then when we move into our final model, one can see that if you look at, for instance, it's moving. We zoomed into Mamelodi, because that's where we, for instance, based on the census flood layer, we found that, those areas are more prone to flooding. So if you can see it like here, if you look at just behind your Mahube Valley or your Mams Mall there, you can see that you start picking those areas that are, vulnerable to flooding. So in terms of discussion and going forward, we are saying, informal settlements in South Africa and in the city of Tshwane are going to be part of us for the near future. So it's something that we are saying it cannot be just solved immediately. So what are the causes of this? First of all, we know that it's because of the pull factors. We have noticed that, for instance, people are more likely to create or to start other new informal settlement in areas that are largely areas of informality. And then people want to come closer to the industrial areas and then social amenities as well as accessing services. And then among the push factors, we are saying we have the irreversible spatial segregation due to apartheid policies. And then we also have high unemployment rates that, force people to leave, for instance, to leave the rural areas and try to come to town to get better employment opportunities. And then we also have this common enemy that, we know it's going to stay with us for some time, of climate change, whereby, people can't live in agriculture like, they used to live before. Because if you look at our rural provinces, the fallow land it keeps on increasing like almost every year. So people are now moving towards the urban areas to look for, better employment opportunities. And then we also have immigration, which contributes to this new informal settlement creation. So now we are saying, for instance, our geospatial technologies, such as like the Earth observation data, can be utilized to monitor the risk of this flooding across informal settlement. And then we are also saying that they can be further used to develop this type of indices where we can indicate which areas are of high, are vulnerable to this flooding. And then we are also saying that, based on these technologies, we can be able to sort of like predict or to sort of like model where maybe where we can say, this place, because of these characteristics, we are likely to have an informal settlement coming up into this area. And then we are further saying that, the use of location data can help us in terms of having spatially targeted interventions and solutions to our problems. And then in terms of policy implications, we are saying, for instance, our decision makers and the policy makers should consider proper spatial disaster management planning. As we have seen yesterday, Dr. Lerato, when he was presenting, we have now this flood intelligence tool that can be used to sort of like, as an early warning of this type of disasters that can happen into the informal settlement. And then we are also saying that, for areas such as these ones in Mamelodi, whereby, we are seeing that, every time when they are flooding, they are affected. We are saying possible relocation should be undertaken to such informal settlements. And then we are also further saying that, more municipal and state land should be made available, accessible, especially for those who are willing to build their own, but cannot afford to buy land. And then we are also saying that, lower rental housing, especially closer to the social amenities and closer to the areas of work, can be a solution as well. And then we are also saying that let our spatial development frameworks be pro-poor so that, we can cater for our colleagues that are at the lower end. Thank you very much.
So there's time for a question, and there was a complimentary question from Anna Mia Lowe that says, this is a great way to show the social impact of Earth observation data. How can the upstream improve their offering to assist your data processing? How can the upstream improve their offering to assist your data processing?
What is the meaning of upstream? Sorry.
So any maybe other institutions or companies, am I right? How can they contribute to improved data processing or improved data quality maybe for modeling?
Yes, I think we are open for, for collaboration. Like in my case, I showcased that, for instance, we are using data from SANSA in terms of the flood layer risk. And then what we are doing with our own model, we are sort of like using the SANSA data, to validate our model to see whether our model is predicting correctly. So I think even, institutions or colleagues that are interested in this field, we are open to collaborate with them. Thank you.
All right, and then there's one more question, and we have time for one more question.
Okay.
Which type of classification did you use when you were classifying your maps in Google Earth Engine?
I'm not a modeler, so I can refer that one to my colleague who is a modeler. Can you respond to that one, Emmanuel?
Thank you. So layers were just merged within the Google Earth Engine, and we used random forest classification.
Thank you so much. Thanks very much. And if there are any more questions, please catch them at the networking session. Hand of applause, please. Our next speaker is Ms. Anela Mkwinkwana from the University of KwaZulu-Natal. Please welcome her.
Good afternoon. My name is Anela Mkwinkwana. I'm a first-year master's student in remote sensing and GIS at the University of KwaZulu-Natal. I will be presenting my honors project, which was based on spatiotemporal monitoring of soil moisture as an indicator of drought patterns in the Kume catchment using remote sensing techniques. Droughts are extended periods of low precipitation that result in water scarcity. Droughts are also classified as expensive natural disasters, and South Africa is no exception in experiencing this disaster. Drought affects environmental, social, and economic factors. Drought can affect the agricultural sector in terms of flow production because of water scarcity. It can also reduce water resources, and it can also decrease the tourism sector, especially in areas where they use water features as their source of attraction. It can also cause displacement of people. Soil moisture can be used as an indicator of drought patterns. Soil moisture can be used as an indicator of drought patterns. Soil moisture is how wet or dry the soil is, and abnormalities in soil moisture can be an indicator of drought patterns. There are different conventional ways in which soil moisture can be monitored. These includes point measurements in the field, even though they have more accuracy, but they are time-consuming and more expensive. And that is when remote sensing has been introduced as a tool that offers the ability to offer real-time soil moisture monitoring. It uses satellite images to derive indices that are related to soil moisture and vegetation indices. The aim and objectives of the study. This study was aimed at assessing drought severity patterns using soil moisture. The objectives include assessment of the extent in which soil moisture has changed from the year 1999 to the year 2023. It was to determine the relationship between soil moisture content and precipitation patterns in the Cume catchment. This study was conducted in the Cume catchment, which is located in the Nkokobe municipality in the Eastern Cape province of South Africa. The Cume catchment also feeds the Beanfield Park Dam, which is used as a source of water in this area. These are the methods that I used. Data was acquired from Copernicus. I used Landsat 5 and Landsat 8 because the study was conducted from the year 1999. I also use meteorological data, which include precipitation and evapotranspiration. Pre-processing was done to remove geometric and radiometric errors. Vegetation and soil moisture indices were derived. Pen sharpening was used on the meteorological data to downscale and to increase the spatiality resolution of the precipitation data. The tesselled curve transformation, which is a tool on the Tesset software, was used to derive the wetness and brightness index. The brightness index is used because it indicates that soil which has more soil moisture is more dark than soil that is dry. And then linear regression was performed for the accuracy of the results. These are some of the results that I got from the study. The Figure 3 shows the prediction accuracy of the wetness and brightness index. Then figure 4 and 5 shows the wetness and brightness index in 2015 and 2023. The results indicate that soil that is very dry is related to soil that is bright, and then soil that is dark is related to soil that is very wet. And then figure 5 shows the drought severity patterns in the Cume catchment. And then these are the different years in which the results show. These include 1999, 2009, 2015, and 2023. The results indicate that the year 1999 and 2015 was the year in which the Cume catchment experienced drought severity patterns. Also, the figure 6 shows the drought area extent, in which it shows some of the areas in which droughts occurred. The tesselled curve transformation components, which are the wetness and the brightness index, reveal that wet soil appears darker and it is less reflective than dry soil. And this is because of the light that is scattered differently between the dark and the wet soil. The vegetation and soil moisture indices indicated significant importance in drought patterns. Vegetation indices were used because vegetation responds to soil moisture. It uses soil moisture for growth, and vegetation that in places where there is less soil moisture, vegetation does not respond well, and then it tilts, and then that leads to a decrease in the growth of vegetation. There was no significant relationship between the precipitation patterns and soil moisture content. This is because of soil infiltration and the holding capacity of the soil. The findings of the study addresses the gaps in the current literature by introducing new concepts that can be used for improved soil moisture content. And this includes the indices that were used. Also, remote sensing can be used for historical data in order to compare the years in which drought occurred. This can also be, also it can be used for the integration of data sets, and also it provides a very high spatial resolution than conventional methods. Thank you.
So there's no questions online, and if I may then ask you a question myself, did you calculate the extent of your study area that was affected by that big decadal 2015 drought?
Yes, I did.
Yeah, what was the extent?
It was the human catchment experienced drought pattern in 63% of the area.
Sure,
There
that's
is-
quite a lot, eh?
Yes.
Yeah.
Okay, sorry. Can I go back?
Yeah,
one
you
slide?
can forward, yeah.
Okay, no.
Thank you very much. Our next speaker is then Dr. Ayadele Periola from the Cape Peninsula University of Technology. Thank you very much.
Good afternoon. I'm from the French South African Institute of Technology, FSAT, at CPUT, a public institution, and conduct research and innovative activities in the space area. I would like to use this opportunity to thank the public for the support. The focus of my presentation will be on an innovative aspect of hosting future data centers in space to save Earth's water resources and also advance artificial intelligence. I want to move to the next slide.
Click again.
So today, data centers play a very crucial role today. We use data centers in communications. They enable us to store our data in the outside of our premises. A lot of the applications we use today are driven by data centers. Use them in storage, use them in search, use them in web support, hosting of numerous number of websites. They also play a very dominant role in social media. Without data centers, social media will not exist the way we see it. But they have challenges. The first challenge is that when you have a data center, you have a large number of servers. And to cool these servers, maintain the electronics at optimum functional temperature, you use a lot of water. The other challenge that arises is that they use a lot of power for the operation of the large number of servers and the cooling. And the use of large amounts of water for operating data centers leads to problems in the area of water scarcity, not having enough water because you have to devote water to cool the data centers. It can lead to drought, it can lead to poor agricultural outcomes, it can lead to lack of water or insufficient water for daily living. So space is being considered as a future host site for data centers because in space we don't have to worry about using a lot of water from Earth. We don't have to worry about outcomes, negative outcomes in agriculture, in finding water for executing daily tasks. But we have challenges in moving to the space domain as well. In the area of how do we power the data center, how do we cool the data center? How do we move from the current existing popular domain of using small satellites and using our experiences to migrate to the point of using data centers in space? So what we've done in the space journey is what is being described here. We usually have a small satellite, and we can aggregate that and have a swarm, a large number of small satellites And then we can have large number of different small satellites. And along the way, different experiences, different levels of skills are built up. So we can basically move from a small satellite and scale gradually to realize big structures like this, based on the expertise that has been acquired and developed from working with small satellites. So we can also have multiple big stations that host data centers in space, because there is some developments in this domain on putting big stations in space, which is gaining traction now. And from there, we can move on to having more robust systems that can support hosting data centers in space. In powering, we've acquired experience in solar panels. It's just increasing the amount of number of solar panels to be attached to a space structure, and then you can operate a space-based data center. Space has a lot of water resources, which is being targeted, has been identified for some years, which can be mined and used to cool data centers. The technology in this area is quite mature now, and water can be reasonably used to operate data centers in space. So these data centers have different use cases. They make life easier in significant number of applications. The first is a data center in space, transferring data from an asset in space to a data center in space has reduced latency. So making decisions are quicker. For near space assets, these are weather balloons. Weather balloons also have a reduced latency in transferring data to space than ground stations in a significant number of scenarios. So it has benefits in reducing the latency of moving our data around. And there's some initiatives in this area. It's from the European Union, some private involvement in this domain, trying to move data centers into space. And when I came for this conference, I met this company as one of the stands, and they are also looking at putting compute power in space. Prior to seeing them, I thought Africa had no initiative, but this is the only private player in this space I've known so far. So a small scenario has been presented showing that we can have space segments, which are, in this case, have simulated these satellites, space-based data centers, hosting a small number of servers to maximum of 6, and then showing how they can interact with ground stations at different locations. So different views showing they can receive data from different locations on Earth, and data can be accessed on request from different locations on Earth as well. So the ground stations have been located in different locations. And this shows, this case has been done for a case where we have data centers in the low Earth orbit. And so there is a variable access in this case. So this is just showing that it's feasible using the benefits of the LEO orbit as we know it. We can have variable points, variable communication windows of accessing our data from space, different times of the day, varying orbits. So in conclusion, we find that space-based data centers are environment-friendly alternative to terrestrial data centers because of the reduced reliance on water, the reduced consumption on Earth's water resources, and they can be used to process data arising from space and near space assets. African initiatives are yet to become widespread, and Africa's expertise, the expertise we've acquired in small satellites, can easily be scaled in leaps to achieve this scenario. Acknowledge the support of our university and the organizers of the conference. Thank you for your attention.
very much. I don't see any questions online, so may I maybe ask a daring question, which I hope you can answer. If they start building more stations down south, will it go faster to download a terabyte of data?
If the, I'm sorry, I didn't get that.
So I see there's a lot of stations north of the tropics of Africa. So it means
Okay.
it will take me quite a lot of time to still download 1 terabyte of data down in South Africa. But if you increase the stations down here, will that speed it up?
Yes, it will.
Yes.
Yes, it will. If there are stations where you want to access the data from,
Yeah.
then the download speed will be better.
It's to our benefit.
It's to our benefits.
Excellent. Thank you very much. A round of applause again. All right, our next speaker is then Ms. Nkosi Ngizwele Ndlovu from the University of Pretoria that is going to present some of her remote sensing work on wetlands in Maputoland.
Okay. Good afternoon, ladies and gentlemen. My name is Nkosi Ngizwele Ndlovu. I am a master's student at the University of Pretoria, and today I'm going to share some of the results that I got for my research project, which is titled Assessing Changes in the Hydrological Regime of Lacustrine Wetlands in the Maputoland Coastal Plain in South Africa. Thank you. So, a lot has been said about the application of remote sensing in various industries and also in environmental monitoring. So, I'm going to emphasize the applications of remote sensing in monitoring wetlands. Firstly, remote sensing allows us to observe long-term dynamics and detect changes over time, which is essential for understanding wetlands in general. And secondly, it provides high spatial resolution, which is essential for surface water monitoring and detecting large-scale and small-scale changes. It also provides us spatial coverage. It also provides large spatial coverage in order for us to be able to monitor large wetlands and wetlands that are located in remote areas that otherwise would be inaccessible. So, lacustrine systems or lacustrine wetlands refer to open water bodies. And you might ask, why are lacustrine systems important and why do we have to study them? Well, lacustrine systems, as they are open water bodies, they help in achieving the Sustainable Development Goal, especially under the Indicator 6.61, which aims at identifying the changes that happen in these systems. So we need to understand how these systems are changing and why they are changing. It is also important for reporting to the Global Biodiversity Framework. Okay, so just a bit of orientation. The Maputoland Coastal Plain is situated along the eastern coast. And awesome. Okay, so it spans from the border of Mozambique up north and extends southwards towards the Tugela River mouth. This area is known for its vast and diverse ecosystems, including palustrine and lacustrine wetlands or wet systems. And the lacustrine wetlands cover 7% of the total area. And these include systems such as St. Lucia, Sibayi, Kosi Bay, and other smaller systems. Okay. So the main aim of this study was to assess the changes
and the hydrological regime of lacustrine wetlands from 1984 to 2023. And the research objectives were looking at the correspondence between wetland extent and rainfall trends, the changes in the hydrological regimes over time, the relationship between extreme rainfall events and wetland extremes to determine the impact of climate change, as well as looking at the extent changes between the wettest and the driest months. Okay. So we collected data, or we used Sentinel-1 SAR data and Lancet data. We used the Sentinel Water Index and the Automated Water Extraction Index to extract the monthly maximum extent of these systems. We then did a monthly average analysis to check how these systems behave on a monthly basis. We then did a hydrological parameter test using TimeSet software, and then we looked at the extent changes in terms of location based on the quaternary catchments. And we also did the extent changes based on the size categories of these wetlands. So when we were doing the monthly average analysis, we discovered that there is a huge extent gap between the large systems and the smaller systems. So the large systems, which is Lake Sibayi and Lake St. Lucia, are dominant, and they range around 25,000 hectares, while the medium systems, which includes the Kosi Lake, range between 1,000 to 2,000 hectares, and the smaller systems range between 0 to 1,000 hectares. Okay. So now, in order to determine if there was a relationship between the extreme climatic events and the hydrological regime of the wetlands, we did rainfall trends, or we analyzed rainfall trends from 1984 to 2023. The figure on the left, it shows the overall trend, and we discovered that there were, we discovered that there were 5 major extreme climatic events. 1984 there, which is relating to tropical cyclone pneumonia. That huge or massive drop there, which is relating to the drought of 1992 and 95. And that massive spike there, which was contributed to by tropical cyclone Elene. The drop there, which is indicating the decadal drought of 2015-2016, and lastly, that spike there, which is the cutoff low system that happened in 2022 and caused flooding in KZN. And on my right, it is the trends broken into different time frames, and as you can see, it shows differences. So from 1984 to 1997, the trend was declining or dropping. Also 1998, the same, and there was a massive drop between 2012 and 2015, but in 2016 to 2023, it started to pick up. Okay. So I hope you still remember the extreme climatic events that I discussed in the previous slide. So, okay, just gonna talk about the colors first. Okay, so the blue blocks there represent the tropical cyclones, the red blocks represent the droughts, and the turquoise there represents the cut-off low system. And these box plots represent the hydrological dynamics of the wetlands. So overall, if we look at row I there, we can see that these systems do not show major changes over time, except for the large systems that show a drop in extent after the 1992 drought. Okay, so moving on to quantify the changes between the driest and the wettest month. So we can see on the slide there that most changes occurred on wetlands that are located more inland, and the wetlands that are located along the coastline show changes varying from 1% to 20%. And if you can see there up north, that is where the Kosi system is, it shows the change of 1%, which suggests that this system is more stable. Okay. So during our community engagement with the people who live in this region, the people from Kosi said that they did not see or they did not experience the effects of the 2015-2016 drought that much as compared to the people who reside in the southern region, especially around the St. Lucia, where the people there said that they observed a decline in the wetland extent. Okay. And we also, as I said, that we also did the extent changes according to sizes. It shows that the medium systems are more stable and they only change by 1%, while the large systems change by 8% and the small systems change by 3%. And the other small systems show a high change rate. And we call these transitional systems because they transition from being inundated to either being vegetated or muddy. Okay. Let me just check my notes here. Okay. So the MCP region is primarily a groundwater-driven system, and it also has dense vegetation as well as frequent cloud cover, which then presents significant challenges in monitoring these systems. So Sentinel-SAR's ability to operate in all weather conditions and at any time day provides the consistent and detailed data necessary to navigate these changes and accurately assess the wetland dynamics. And to fully comprehend these ecosystems and how they are changing, it is essential for us to continue monitoring these wetlands over the next decade and beyond using the SAR data. So this long-term observation will allow us to capture the full spectrum of natural variability and better understand the impacts of climate change and human activities. This sustained monitoring is not only essential for scientific understanding, but also for reporting to global frameworks such as the GPF. So the accurate and long-term data will ensure that we can meet our commitments to biodiversity conservation, providing insights that are needed to protect these ecosystems and inform global biodiversity targets. Thank you.
Thank you very much, Nkosi Ngizwile. There's a comment from Joyce that says, beautiful study done. Did you do data validation in your analysis? What was the source of your in situ data? Data validation. Did you go and do field work?
Okay. Joyce. Okay, Joyce. To answer your question, I didn't do field work, but I did go visit the study area and just observed the changes that were happening there. Data validation.
Yeah.
Okay.
No, I think it's quite challenging to go back in time, especially with Des Moines, and there isn't much reference data, especially for 1984, for example, that we looked in, and that extent hasn't been properly mapped through remote sensing because of the cloud cover during these extreme events. So pick up the conversation during the network session, please.
Yes.
Thank you so much. So I'm the next speaker, Dr. Heidi van Deventer. I'm from the CSRR, and I really have a passion for wetlands. And my talk is about monitoring changes in the extent of lacustrine wetlands. I was over-optimistic of Eswatini, Lesotho, and South Africa. I have some results for you. Here's it. So just contextually, to again remind us, globally and in South Africa, wetlands are considered the most threatened realm. And it's estimated that over 80% of the extent has been lost or degraded. But we still don't have accurate results or statistics because we don't even have full representativity maps that shows where these wetlands are. But this is from the International Panel on the Biodiversity and Ecosystem Services. So it's a global study that's been done. So globally, there's also been products generated from both Landsat and Sentinel at a 30-meter spatial resolution. It's called the Global Surface Water Product by Piekel et al. In 2016. And this has been used for the reporting to the Sustainable Development Indicator 6.6.1a as one of the biomes. So there's two wetland biomes. The one is lacustrine, open water systems, compared to palestrine, the vegetated systems. And as you can see from the top left map, most of these are located in the northern hemisphere, and you wonder what is the accuracy and the representativity of those for the southern hemisphere, and especially in the temperate environments. So in a previous study where we've assessed how representative is the global surface water product for South Africa, it showed that 11% of the extent of our wetland map 5 was considered to be open water and the rest are vegetated. But yet, we still have to see, can we improve on the representativity and the monitoring? Another factor to consider is the essential biodiversity variables that's being used to monitor freshwater. And you can see there's quite a long list here, but I want to point you to the one at the end, the ecosystem function, where the hydrological regime metrics can be used to assess changes in the extent of wetlands over time. Now for Landsat, that's quite difficult because we had so much cloud cover with the optical sensor. But the new data that Mark Thompson through Deutera Image have produced, the Mzansi Amanzi data layers, was then bought up by SANSA and provided freely for use. They published an article in 2018, which you can follow and find on the internet, and that shows that they use a decision tree-based algorithm to derive the extent of open water at a monthly interval from the Sentinel-2 optical images, and later they included then Sentinel-1 radar as well, which will really address the issue of cloud cover. And that's where the link is now that you can follow up and download and use it yourself. The process that I've taken for the number of records to calculate it is first clip the whole to the study area that includes South Africa, Eswatini, and Lesotho, then assign an occurrence code of 1 for each month, union all the months into the 69-month layer, polygon layer. I did not use raster analysis because I wanted to union it with the latest National Wetland Map 6 extent that was issued by SANBI. That's the South African National Biodiversity Institute in April this year, as well as the artificial wetlands that's been previously mapped in 2019. So I had to filter out what was considered to be others that was not confirmed to be artificial or natural wetlands. But yet, in one of the slides, I will still report on it. And then also, the total number of records was 54.7 million records, so it became a little bit challenging on my laptop, and I've got a very good laptop. And therefore, I started filtering out some of the data that if a pixel has been inundated only once a month, I did not consider that to be lacustrine. So I filtered out the records on the right-hand side. You can see that for most of the provinces, it was more than 73% of the original records, except for the Northern Cape, 66%. Then went across to calculate the hydric period. Is it permanent, seasonal, ephemeral? what is the frequency per month and type, do a stationarity test, the augmented Dickey-Fuller test, the overall trend, the Mann-Kendall trend, and phenological metrics in TimeSat. So when you do a Jenks natural breaks of 5 classes, you can see that most of, or there's quite a nice break above 75% of the 96 months that could be identified as permanent. And then the other 2, I've grouped the first 2 classes as ephemeral and the other 2 as seasonal. And you can see on the map that the distribution almost follows quite a lot of the rivers and our large water bodies such as the Fall Dam and St. Lucia, and look at the high amount around the strategic water source area of the Cape Fold Mountains. But if you start looking at the percentages of these, you can see that the hydro period, the ephemeral one, is 62% of the total amount. And I just don't know how we're going to validate that, because it does look like it overlaps with quite a lot of the vegetation and is more maybe vegetation moisture as opposed to an open water body. And therefore my decision was to focus on the permanent and seasonal ones and use Gauteng then as an example of how the statistics look like at 3 levels. So the first level is confirmed wetland or other. Second level, natural, artificial, and other. And the third one is the biodiversity types that's used in South Africa, the hydrogeomorphic units, and again, other. So you can see that the other pixels are dominating the distribution and hasn't been validated by any of the wetland experts yet. They need to be considered and validated for consideration, but otherwise my reporting would be just on the wetlands, whether they're artificial, natural, or confirmed any of the hydrogeomorphic units. This is the result then for Gauteng, and the percentage of open water that is permanently inundated is 6% across the 96 months, which is interesting, between a drought and a severe wet season in 2022. So the outlines have been enhanced slightly so that you can better see it as well. And the seasonal systems are 2%, which we still don't know if those are the fringes of the wetlands, where you do sometimes have open water, but then they change to reeds or vegetated marsh and sedges. But otherwise, 92% of the extent of these pixels were then ephemeral and not confirmed to be wetlands. If you look at the overall changes for this 96 months, at the top shows the changes of all the wetlands, and it appears as if there's an increase in the trend. And you can see a strong seasonal signature of it. But if you look at the permanent systems in dark blue, the trend was, it was not stationary, but it was not a significant increase. And just in comparison, the lighter blue are the seasonal systems that are also showing it's not stationary, but it was a significant increase. And then the ephemeral systems also show an increase in the very wet year of 2022, which again could be vegetated systems that transition to open water during that time. So just comparing the changes in artificial and natural systems for the time period, again, the outliers, you can see the very big systems, usually the artificial systems are dominating and very seasonal at the top. But you can see that increase around 2016 here on the left, and very dominant smaller systems that are peaking in their extent for both natural and artificial systems. Looking at seasonality of the natural, artificial, so natural at the top and artificial at the bottom, and distinguishing permanent and seasonal systems, it was very interesting. Dr. Piet Louis Grindling, a friend of mine at the Department of Forestry, Fishery and Environment, said to me, the river systems in the Highveld flows at the highest peak in the dry season. And I thought, oh, Piet Louis, where's your evidence of that? And lo and behold, here's the evidence. All of these systems peak in the dry season around June and August. June, July, August is the peak of the season. So everything that rains between our peak rain season around February actually infiltrates, and then the groundwater fills up, and then it starts feeding our wetlands. Looking at the phenological metrics just of the natural wetlands for the permanent and seasonal ones, you can see the drought impacting there in 2016 again. There is a very low drop in November 2019, which could be very dry, And there could have been some cloud cover there that affected the signal in a very wet season. And in this graph, you can see how the extent changes relative to the average seasonality of it, and then also how the trend changes and drops in 2019, much more compared to 2016 average drop, but you can see that the graph is much lower compared to the 2016 one as opposed to 2019, and how it then peaks in 2020 thereafter. So the duration is on average 7 months, and then the end of season around September and October, but the systems do slightly differ. And these are very useful metrics to track climate change against. So you can measure whether the magnitude is changing, the duration, or the onset or the end. Just 4 of the 13 metrics that can be calculated. But then taking it down to the biodiversity types, if you can see that most of the systems on the right-hand side are all the natural wetlands, and this is the artificial wetlands. Artificial wetlands have quite an extent of 25% that are typed as being permanent and seasonally inundated, whereas the other systems are really very little. So what does that mean for monitoring wetlands? We cannot just rely on open water indices and remote sensing. We must use the other EBVs, such as vegetation structure, communities, and tracking changes over time to monitor our wetlands, because they are not predominantly open water systems. So for reporting to the Sustainable Development Goal, it was interesting that they are aligning now to the 3-year RAMSAR reporting that's been done, and 2017 is going to be used as a reference baseline, and so tracking changes from this graph for our Gauteng wetlands show that there is going to be minor changes if you look just in extent. And you can see the permanent systems are relatively stable, but the moment you change it to percentage, then you can see that slight shifts that happens in correspondence to the droughts and wetter years. So I think Sentinel-1 and 2 has been amazing in contributing to the monitoring of wetlands in this country and enables a refined reporting compared to the coarser scale data of 30-meter spatial resolution. But some of the key issues, and like Joseph also mentioned, is how do we validate this? Who's going to have funding to send me out every month to go and validate the extent of these over time? So there is a bit of where we have to rely on the census to help with the reporting, and it would be great to get funding to go and validate strategic areas. But we can see that the systems are visibly changing, and I look forward to processing the rest of the provinces and the other countries. Thank you very much. Let me see. Anna Mialo is asking, how would more regular monitoring or data capturing affect your research? I think the question is just whether the edges, are we capturing the extent of the systems, maybe in their very wet and very dry season accurately? Is the representation at a 20-meter spatial resolution accurate? I would focus on that, on the permanent systems, and not go to ephemeral and seasonal. But at the same time, while you're transecting to the main part of the open water body, you may walk through your marshes and sedges and reeds and can actually just validate that extent and see is the algorithm over predicting or not. I hope that answers the question. Thank you very much. There's an anonymous one. Based on your assessment, were you happy with the accuracy of the data received from the Amanzi data? Yes, I think it's an absolutely amazing data set. And I met Mark now also, Mark Thompson, during tea time, and we said we want to sit down together just to look at all those other pixels and see, is it radar prediction of vegetation moisture, and maybe we can bring that in some validation. I don't think we can do without this Amanzi data. We really need to expand. Anybody from universities, please bring this into your student research as well. All right, I'm going to hand over to our last speaker, Mr. Benjamin Makote. He is doing his master's degree at the Wits University and working at Harmony Gold Mining Environmental. Thank you.
Program Director, esteemed guests, attendees, good day. Khotso. I'm Benjamin Makobe, a graduate from Wits. I graduated this year with my master's. So I'll basically present you my project, monitoring the invention. Even today I can't still pronounce the scientific name. It's a pom-pom weed using a novel mark stand and machine learning assembles in the Cradle Nature Reserve. Okay, these are the people who supervised my project, Prof. Paidam Hangara, Dr. Eskaida, and Dr. Mahlatsi. I'll be presenting a snippet of my project, so for full overview, you can access my journal on Google Scholar. It's already published. When you read on the media locally and globally, the pressing environmental issue is climate change. It has gained attention worldwide. Countries are urged to revolutionize their industries, adopt environmentally friendly initiatives, renewable energy, wastewater treatment, circular economy. While climate change has gained international attention and awareness are being raised, however, the awareness on the dangers of invasive alien plants is less publicized. Climate change, in a sense of rise of carbon dioxide, temperature fluctuation, are likely to propagate the spread of invasive alien plants and reducing biodiversity. Okay. Human migration is singled out as the contribution to alien plant invaders, the transportation of goods and people within countries. In agriculture, the need of invasive plants has necessitated the rapid spread of invasive plants. Some plants were needed for pest control. The alien plants are non-native plants introduced into new locations intentionally or accidentally by humans. The invention of invasive plants have economic and ecological effects, altering the functioning of indigenous ecosystem. The invasive alien plants are considered the second largest cause of biodiversity loss. Therefore, globally, accurate and detailed information on the spatial distribution is needed to maximize effective control mechanisms. On country level, South Africa is also conducting studies to understand the status and spatial distribution of invasive plants, as that information might assist in rehabilitation of the affected areas. Okay. Consequences of alien invasive plants: they compete with indigenous vegetation for space and water retention. And remember, South Africa is a water-scarce country. There's reduced rangeland capacity for livestock and game animals, thus threatens biodiversity. It necessitates wildfires. Approximately 6 million is spent on the rehabilitation and control measures. The control measures that are being done are mechanical, the uprooting, the chemical spraying. And on the picture here, it was us when we visited the study area. They were using it was during the awareness of the pom-pom weed, so they invited the community to come and help with the eradication, but they were using mechanical of uprooting. Okay, sorry. Remote sensing has offered opportunity to counteract the traditional method of terrestrial mapping, of which are expensive, laborious, and time-consuming. The availability of satellite products such as the European Space Agency Sentinel-2, Worldview, and the UAVs has improved on land monitoring purposes. They improved the science of obtaining comprehensive spatial data on the distribution of invasive plants. Therefore, timely and accurate spatial data on invasive plants is required to enhance knowledge on the spatial trend patterns of invasive plants, to inform best environmental practices, and to allocate resources to mitigate and management. These are the NASA products and the Sentinel. Okay. Let me move forward to my project. So in the history of remote sensing, spectral signatures have been used to detect alien invasive plants, because on the electromagnetic spectrum, different vegetation exhibit different spectral signatures. However, we have seen the integration of classification algorithms as well. Sorry, can I go back? Study had revealed that different vegetation exhibits different spectral reflectance within the regions of electromagnetic spectrum, enabling the ability to assess vegetation, plant, and biochemical properties, such as the NDVI and the Enhanced Vegetation Index. Okay, the species that I was studying is pom-pom wheat. Is this one that is pinkish purple, and this was asked during the field data collection. Okay. The pom-pom wheat is native to Central and South America. The perennial erect herb is 1.3 meter to 1.5 meter high. It flowers in spring and then dies in winter. The wheat has fluffy pink flower heads with light green leaves that are scattered around the full length of the stem and clustered at the base of the plant to form like a rosette. In South Africa, pom-pom wheat was introduced in the 1960s for ornamental purposes. However, between the 1990s and 2000, it entered a dramatic expansion, becoming an exotic wheat. 7 out of 9 provinces of South Africa have been, pom-pom wheat has been recorded. Gauteng province recorded high infestations. So this was the study area. The Greater Cradle Nature Reserve is a World Heritage Site for its unique biodiversity. It was accorded the heritage status by the UNESCO, and as well as a research intent site for archaeologists and paleontologists. The pom-pom wheat is declared Category 1B exotic wheat in South Africa. It is threatening the conservation of grassland and savanna biomes in the Highveld. The pom-pom wheat infestations is causing environmental degradation and threatening the biodiversity, as I mentioned. Okay. The aim of the study to model the spatial distribution of, at the Cradle Nature Reserve using Sentinel-2 multispectral product. The objective of the study are as follows: to assess the efficacy of support vector machines and random forest to accurately detect pom-pom wheat against the coexisting vegetation using Sentinel-2 multispectral data. We downloaded 2019 and 2024. And to model the species using Maxtent species distribution model to strengthen the machine learning findings and to recommend effective invasive mechanisms. Field data collection. The data was collected on the 25th and 26th January 2024. An initial site visit was done June 2023, when it has completely died. There was nothing at the nature reserve. And then we went back November, it was starting to flower. But because of the erratic rainfall of the year 2023, it flowered late. The Sentinel-2, that's the satellite imagery we used. These are the machine learning algorithms we tested: support vector machine and the random forest. As they are explained, the support is supervised machine learning. And these are non-parametric classification models. Then we used a Maxtent species distribution model. It's frequently used in ecological studies. It has the ability to forecast the current and future spatial distributions of invasive plants. It's an open source software and it's user-friendly, computer efficiency. So you only acquire the locations of the target species. In our case, we use the GPS points to get the location of the species, and then we import them to act ArcGIS, and then we converted them to ASCII. Then the environmental data, rainfall, soil temperature, were downloaded from NASA Power Data. Okay. Okay, these are the results. I will have to move fast. So, at the top is Random Forest 2019, Random Forest 2024. Yeah. So we tested if whether the Random Forest and the support vector SVM, they can help us to accurately detect a pom-pom weight on the satellite imagery. And then we can see with the green, with the green color that the pom-pom weight was visible, was there in 2019, and then even in 2024 it was there. Then the support vector machine also showed that pom-pom weight was visible, and then even in 2024 it was there. However, the 2024 results, they complement our visual analysis on the field. The Cradle Nature Reserve was highly infested by pom-pom weed. So support vector machine into our result outperformed Random Forest. We used Pearson's correlation to test the efficacy of the two models. And then the traditional confusion metrics were used, and then our kappa statistics and overall classification were above 75%. Okay, these are the changes in aerial coverage from 2019 to 2024. Pom-pom wheat has aggressively encroached in the nature reserve. This is the Maxtent modeling, of which it uses the presence-only data, the GPS locations of the pom-pom wheat, and then we also incorporated the environmental variables, the soil, temperature, elevation, they classified the land cover to predict the future distribution. So according to the Maxtent, it ranges from high to low. Where there's a red, these are pom-pom where it's highly invaded. Even here on the central, there's a lot of pom-pom. So this can help the nature reserve people because they're busy with their rehabilitation. So it can help them to prioritize areas that are highly infested with pom-pom to rehabilitate them first to avoid further spreading. So this is the Maxtent model. And then based on the result, we found that soil and rainfall were the environmental contributor, meaning that pom-pom wheat, for it to be able to flourish, it was because of the soil and the rainfall as well. Land cover had less influence. Jackknife, these are the pom-pom, okay. Then these are the results. Soil had 44.8 contribution, temperature 29. They necessitated the proliferation of pom-pom wheat. This is the Maxtent evaluation model. To evaluate the efficacy of Maxtent, the area under curve, we obtained 0.92, and then it's an excellent accuracy. Yeah. The encroachment of pom-pom wheat increased in the nature reserve from 2019 and 2024. The support vector machine was a robust classification model in accurately detecting pom-pom wheat against the coexisting vegetation. Environmental factors, soil and rainfall were identified as significant contributors to pom-pom wheat infestations. Based on the predictive model, rehabilitation should be prioritized on areas identified as high habitat suitability. So the soil chemistry needs to be investigated, and the land disturbances during construction, and the carbon. Usually pom-pom wheat, you'll find it alongside the roadworks. So the carbon from the automobiles, we think it can contribute to the infestations. So we recommend further research to determine whether the carbon from the vehicles cause pom-pom wheat to grow along the roadside. Yes, okay, the power of remote sensing to obtain spatial data and the effectiveness of remote sensing in mapping spatial distributions. And the advantage of remote sensing is obtaining historical data. And the Sentinel-2, the red edge band, played a key role in pom-pom wheat detection. Okay. I'll jump this. Okay. Thank you very much.
Thank you so much, Mr. Makote. There's one question online. It was actually posted by Dr. Pariola using my phone. How do you say pom-pom in isiXhosa and isiZulu?
There's no, I thought there's an African language for pom-pom. There is? No, there's no one.
If there is, please post it in the chat.
Okay, I'll give it one, I'll think about it.
Oh, yeah, you can. And then there's which control method is more effective when controlling the pom-pom weed, and how does the pom-pom weed spread in different environments?
So far, I don't think there's any effective control mechanism that can be used. So pom-pom is spread through, it's wind dispersion. It's fluffy, the flowers are fluffy and it's spread through wind dispersion. And then if the environment is disturbed, pom-pom weed just grows. And then usually vehicles, people moving around, that's cause the pom-pom weed to grow. So the spraying, usually at the Kruger Nature Reserve, they said they started rehabilitating pom-pom from September. So if we're able to do change detection, to check from, they said 2020, somewhere they started treating, from 2020 up until now, to assess if there are rehabilitation methods are working. Because according to them, they say it's working. But we want to check scientifically if they're spraying and uprooting. Because there is quite a few people are working on the ground, and it's a 3,000 hectares in nature reserve. It's quite big. And some areas that are inaccessible, you can't access them. So we really need to check if the money that is spent on rehabilitation, is it effective? So we can expand on that.
If I may comment on that, the World Heritage Site isn't a nature reserve, so there isn't an authority that manages it. It consists of private landowners. And I do think you must take your work out to them and post it maybe on a web map service that they can see. At Colburn, what's working effectively is heading, for sure, but otherwise a tree popper. It's manual work.
Yeah, because they just uproot it and then the next thing they leave it there and it just grows.
Then there is one more question. That's going to be the last question for the session. Dr. Tabini Mazibuku is asking, how are you intending to implement the recommendations of your study and involve other young leaders to use this space-based technology to achieve these SDGs 13 and 15?
Okay, so far, I don't have a plan on how I can implement it. So I guess me presenting here, one can help me to take it forward. So I believe we should raise awareness with public servants, NGOs, we should come together, and because less is known about the invasive plants. So I believe raising awareness will help us to reach to the people, and then they know how we can use the space technology to address the issue of biodiversity loss.
Definitely.
Yeah.
Thank you very much.
Thank you.
Thank you very much. And then just the last round of energetic response and applause for all the speakers. Thank you very much. We kept to time. Thank you. Thank you, everybody.
Okay. Not a problem.
Thank you to you, Dr. Heidi van der Venter, and your team of panelists on that discussion about integrated environmental monitoring. What a robust day of discussions we've had that started with the commercial space ventures and sustainable growth, and then we had that technical session about building resilient space infrastructure and operations for a sustainable future. And now we've concluded with the showcase, which is a follow-up from the one that we had yesterday, and today's was all about integrated environmental monitoring. Leaders, thank you so much for your time and your attention. Today was day 2. It was all about space and economic sustainability, and we examined the economic impact of space technologies with a strong emphasis on the potential to drive innovation, foster economic growth, and sustainability. Tomorrow, the conversation is going to shift to space and the future. A very exciting lineup yet again in store for us, so please let's gather again tomorrow at the same time with a 9 a.m. start. I did, when I started, say that we're going to start on time, end on time, and waste no time. And I'm so grateful to you, Dr. van der Venter, for your support in making sure that we didn't start on time, we didn't quite end on time, but at least we're 6 minutes over, and it wasn't as bad as it was, I believe, yesterday. Thank you so much, leaders, for your time and your attention. It's been an honor being your MC today and your director of time. We'll meet again soon. Let us gather, though, at the networking session that's taking place now. I believe if you haven't left now, you're going to probably be stuck in traffic, so you might as well come over to the network session and kill some time. Let's network there. My name is Maud Nale. Until we meet again, take care.